Welcome to EDU World Space.
Okay, so we're doing chapter 22, problem 3 here. So it says a cube of side lengths L is placed in a uniform field, electric field E naught, with edges parallel to the field lines. Okay. So part A says, what is the net flux through the cube? Okay, so if the field is uniform, no lines originate or terminate inside the cube. So if we think about this being our cube here, variably poorly drawn cube, our electric field is coming in here. It's uniform across all space, so the electric field going through this area is the same going out. So that means we know that the electric flux must be 0 because no lines originate or terminate inside the cube. Awesome. Part B. Part B says, what is the flux through each of its 6 faces? Okay, so this was the net flux, right? But each face itself is going to have its own flux. There are 2 opposite faces with field lines perpendicular to the faces, and the other 4 faces have lines parallel. So that means 2 of the faces are perpendicular to the field lines, and 4 of them are parallel to the field lines out of 6 faces, because there's 6 faces on a cube. So for the faces parallel to the field lines, these 4, no field lines enter or exit, because the field lines are going like this. This is the face of the block. So none of them are going in or out of that face. So that means for the 4 parallel faces, the electric flux is 0. Cool. So now we just have to figure out what is the, let me draw that better. What is the electric flux for the perpendicular faces? We have 2 of them, right? So this would be like this face that it enters and the opposite one that it's exiting. So one of these faces, as I said here, has the field lines entering it, and the other one's going to have it exiting. So, and we also know the net has to be 0, so they're going to be equal and opposite. So we can say the electric flux in equals the negative electric flux out, because we already said the net flux has to be 0. And these are the 2 perpendicular faces. So we know that's how they're given. So now let's find the electric flux entering. And this is given as the magnitude of the electric field times the area. And the area is L squared because it's a cube of side length L. And now times the cosine of the angle between them. So if the angle is coming, or the area vector is coming out normal to the surface, that means the angle between these are going to be at 180 degrees. The angle for these are going to be, or the outing is going to be at 0 degrees. So this cosine of 180 is -1. So that means this is negative E naught L squared. And based on our relation above, we know that the electric flux on the out face must be the opposite of this, or E naught L squared, which we also would have seen because cosine would have, the theta would have been 0 degrees, and the cosine of 0 degrees is +1. So it all checks out. So there's the one face, here's the other face, and all the other 4 are 0. Awesome.